guys, wanna know how our food is nutritious or not? Let's watch our video to know about basic chromatography in food industry.
What is chromatography? Chromatography is a method used to effect the extremely small-scale separations of two or more dissolved particles within a solution. Greek words chroma and graphenes represent color and writing, respectively. The method originally applied to the separations of colors. Chromatography can be classified into different types based on the following categories based on the physical state of mobile and stationary phases. The different types of chromatography are adsorption chromatography, liquid chromatography, ion chromatography, and gas chromatography.
Theory and application. Chromatography is a laboratory technique used to separate, identify, and quantify the components of a mixture. It's based on the principle that different compounds have different affinities for a stationary phase and different migration rates through a mobile phase. In the food industry, chromatography is widely used for various applications. In quality control, chromatography is used to monitor the quality of food products, checking for contaminants or adulterants. It's also used to detect and quantify foodborne pathogens such as Salmonella and E. coli. Chromatography is also used to verify the authenticity of food products, detecting the presence of additives or contaminants. It's used to monitor processing conditions such as temperature and pH to ensure optimal food quality. In food analysis, chromatography is used to analyze the chemical composition of food products, detecting the presence of pesticides or heavy metals. It's a powerful tool for ensuring food safety and quality. Overall, chromatography is a crucial technique in the food industry, helping to ensure the quality and safety of food products. Gas chromatography. Gas chromatography is a laboratory technique used to separate, identify, and quantify the components of a mixture. It's based on the principle that different compounds have different boiling points and retention times. There are two main types of GC. First, open tubular, which use a narrow open tube as the column, and capillary, which uses a thin, narrow tube as the column. Gas chromatography is widely used in various fields, including quality control, research, and environmental monitoring. In quality control, gas chromatography is used to monitor the quality of pharmaceuticals, foods, and environmental samples. In research, gas chromatography is used to study the chemical composition of biological samples, such as blood and tissue. The gas chromatography process involves injecting a sample into a heated injector, which vaporizes the sample. The sample is then separated on a column coated with a stationary phase, which is typically a liquid or a solid. A carrier gas such as helium or nitrogen is used to transport the sample through the column. The separated components are then detected by a detector, which measures the amount of each component. Gas chromatography is a powerful tool for analyzing complex mixtures and identifying unknown compounds. It's widely used in various industries, including pharmaceuticals, food, and environmental monitoring.
What is high-performance liquid chromatography? It is a powerful analytical technique used to separate, identify, and quantify components in a mixture. For example, we want to quantify vitamin C, which is ascorbic acid, and other vitamins such as B1, B2, and B6 in commercial orange juice using HPLC. So we begin with by preparing stock solution of vitamin standards, which are ascorbic acid, thiamine, riboflavin, and pyridoxines. diluted to 1 mg per ml in suitable solvents. After filtering the orange juice to remove particles, we extracted the vitamins using metaphosphoric acid for vitamin C and acidic solution for B vitamins, followed by dilution to optimal concentrations. Using a C18 column and a phosphate buffer pH 3 mobile phase, we conducted HPLC analysis with UV vis detection wavelength set at 210 nm for vitamin C and 254 nm for vitamins B1 and B2, and lastly 270 nm for vitamin B6. Calibration curves were generated using standard solutions and chromatograms of the orange juice samples were analyzed. Integration of peaks areas allowed us to quantify the concentration of each vitamin, ensuring accurate nutritional assessment of the commercial orange juice.
Other types of chromatography is ion chromatography. Ion chromatography is used for water chemistry analysis. Major cations as well as anions such as lithium, sodium, ammonium, potassium, calcium, and magnesium can also be measured with ion chromatography. Examples of major anions include fluoride, chloride, nitrate, nitrate, and sulfate. Concentrations of organic acids can also be measured through ion chromatography. Ion chromatography is a type of liquid chromatography that separates ionic species according to how it interacts with a resin in order to determine their quantities. Depending on the size and types of species, ionic species separate in different ways. A compressed chromatography, his column is filled with sample solutions and the column's content absorb the ions. The absorbed ions start to separate from the column as an ion extraction, liquid or eluent passes through it. The ionic concentration in the sample are determined by the times of the various species.
Size exclusion chromatography, known as gel filtration chromatography or gel fermentation chromatography, is a technique used for separating molecules in a mixture based on their size. Separates molecules according to their size, shape, and molecular weight. Usually applied to large molecules or macromolecular complex such as proteins and industrial polymers. There are three types of size exclusion chromatography. First, principles. Molecules are separated according to their size. Small molecules penetrate the small pores in stationary phase, while large molecules do not. Second, analysis. By plotting the elution volume or time against the concentration of eluted material, a chromatogram is obtained. Lastly, sample loading. The sample, which is usually dissolved in a suitable solvent, is injected onto the column. As the sample moves through the column, it encounters the matrix. Importance of chromatography. There are three importance of chromatography. First, quality control in industry such as pharmaceutical, food, and beverage, and even manufacturing. Chromatography ensures product quality and safety by detecting impurities or contaminants in samples. Second, food analysis. Chromatography is widely employed in food analysis to determine the composition of and safety of food products. It enables the detection of additives, contaminants, and residues, ensuring compliance with regulatory standards. And lastly,
In summary, chromatography, especially HPLC, is essential in food industry for ensuring product safety, quality, and nutritional accuracy. It provides precise, accurate, and reliable analysis of various food components, helping maintain regulatory compliance and consumer trust. As a versatile and powerful tool, chromatography continues to be indispensable in advancing food science and quality assurance.
Thank you guys for watching this video. Make sure you have like, comment, and click the share button so that others will get this knowledge too.